To find the vertex of a parabola, we need what we call vertex form. So we want to take my standard form of a quadratic, and we want to convert it to this vertex form. And vertex form is y equals a x minus h squared plus k, such that my vertex is h. Okay, now you need to really be careful about the sign on the inside. If it's a minus h, a positive h comes out. It's opposite of that sign. Now, when we think about this idea of converting it to vertex form, we must recall that this quadratic is a rectangle. That's why the prefix quad. Quad means four-sided figure. It's going to be a rectangle. Now, rectangles have sides that aren't always the same length. We want to make a special rectangle called a square. Why would I want to make a square? Well, if I go back and look at the power, the exponent on a quadratic, it is a square. So I'm going to convert these into squares, i.e. we're going to call this method completing the square. So to look at it visually, I think will help. We have some items called algebra tiles. Algebra tiles are shapes. I have a big square, which we're going to call x squared. I have this stick shape, and I'm going to actually draw it with sticks, and that is going to be an x. These are going to be the same height, because x by x is x squared for an area. 1 by x is x, so this little shape here that's the same width is 1 by 1, or just a single. So we're going to take these shapes, x squared, my 4x's, which are the same height or width as the x squared, and these two singles, and I'm just going to use dots for the purpose here. We're going to arrange them into a square. So first I'm going to take my x squared, and I'm going to take my 4 sticks, and to make a square, I know that they must have on a square the same dimensions on each side. That's the meaning of a square. The dimension on the edge also has to equal the dimension on the top. Now to fill it in, I need 4 of these, so I completed a square. Do you see a square? This is a perfect square. And so we're completing the square. So what are the dimensions? Well, if you recall, this edge was x, and these were each 1. So I have a plus 2. This is x, and each of these are a dimension of 1. So I have an x plus 2. So there's my square. So looking at my tiles here, I had an x squared plus 4 of those sticks plus 4 of these singles. I'm going to use that because that was a complete square. I can't forget about the 2 that I had. I'm just going to put them on the edge. So to complete this square, I had to put 4 in, so I'm going to take 4 off. So I'm just counterbalancing what I put in to make the square to take it off. Now, if I look in combined terms, I'm back to my original because the 4's would cancel each other. So I made a complete square, and I can look at my dimensions of x plus 2 is my square. And then combining these, minus 4, I am now in not standard form, but vertex form. Negative 2, watching your sign again, negative 4 is my vertex. Now we must be careful here. I believe that's negative 2. 2 minus 4 is negative 2, so this should be negative 2 as well. Careful of your addition. Let's try another one. Once again, using my pieces that I have. Here's my x squared. I have 6 of these lines or sticks. So I'm going to put a 3 by 3. And now I have 8 that I need to complete the square with, but I need to use 9. There are 9 needed to make this square, which is x plus 3 on one side and x plus 3 on the other. There's my square. So I have x squared plus 6x plus 9 dots making the square. I had 8 of those, but I put in 9. So I'm just counteracting these two that completed my square. My square ended up having dimensions of 3. And I just combined my singles. I didn't have enough. I was one short, if you want to think of it that way. My vertex, -3, -1. We'll try a third problem. Once again, I look at only these two pieces. I'm going to fudge these. I'm going to make as many as I need. Here's my x squared. Let's see, I have 10 x's. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to split them evenly. Now, if I counted up all the dots I needed here, it looks like I would need quite a few, 5 across for each one. I would need 25 to make this square, which is x plus 5 on one side and the other x plus 5. So I had x squared plus 10x. I needed 25 to make my square. That makes my square. I cannot forget that I had 5 of those already. So I'm going to take off the 25 that I put in. So I'm balancing. And my square is going to be x plus 5, which we can see visually above. And I was short 20 of those dots. That's why it's -20. And my vertex for this quadratic would be -5, -20. So that's how you find vertex. It's from completing the square. I like to draw a picture. There is another, we call it an algorithmic way to do it, kind of a recipe, but I think if you can see the picture, it works out nicely. You can tell exactly how many you need, so I'm just balancing, and I'm using what we call algebra tiles to do that. The algebra tiles, again, are a big square for x by x or x squared, a stick, that's why I've been drawing sticks here, which is x by 1, and this distance is 1 by 1 for the singles.